Hey everybody, video number 5. This one's going to be a second. This is definitely one I would normally use the smartboard for a lot, but I got it all animated, so it should all work out. But you're going to have to listen to some of the numbers because some of the numbers I'm going to say and not write because I don't have that handy dandy pen. After today, I can use Table G to classify solution as first saturated, unsaturated, and supersaturated. We just went over those a little bit last video. And then given the amounts of solute and temperature and the amount of solvent, I'm going to be able to play games, right? And then I can change the amount of solute if the temperature has changed or if the volume has changed or something. Okay, so let's get right to how we do this. So if my plot on table G ends up right on the curve, I say that it is saturated. So on the curve is saturated. Let me tell you what I'm talking about. So here's an example. 40 grams of NaCl at 90 degrees. So I'm going to run up 40 grams, 90 degrees. Those cross, and look, I'm right on the line of NaCl. Okay. And saturated again is a solution holding the maximum amount at that temperature. Okay. Notice it's right on the line. Then, if my plot falls below the line, so that is unsaturated. Let me give you an example of what I'm talking about. 70 grams of KNO3 at 60 degrees. So I'm going to plot those 2 points. 70 grams is on the y-axis. Temperature is on the x-axis. So I'm going to plot those 2 points. And then I'm talking about here KNO3. Notice that line is the top line. And this dot is below that line. Below the line means unsaturated. Okay? And then I can plot it and have it become, oh, wait, let me define unsaturated one more time. My bad. Holding less than the amount I should be able to at that temperature. Now I can talk about above the line. If the plot ends up above the line of interest, then I am what we call supersaturated, is how that works. So an example, 110 grams of NaNO3, 110 grams at 20 degrees, and notice that dot is above NaNO3. I should only be able to hold at that temperature something like 87 or 88 grams, and I got in 110 somehow. So that is super saturated. Okay, that is the first way we use this big old bad table G. Saturated, unsaturated, super saturated, just where it is. Then the games start. So let's get into some table G games after we, of course, define one last time what supersaturated is, holding more than I'm supposed to be able to. Okay? Okay. On to games. Finding how much solute will not dissolve. So some words first on how to do this. So I'm always going to take the mass that will dissolve minus the mass that is added, and that is going to equal the mass that does not dissolve. So a little bit of math. See how it's mass minus mass equals mass. Okay. And what you're going to do is you're going to use table G to find out the amount that will dissolve at both temperatures. We're going to plot them, and then we're just going to subtract the two values. That's pretty much how all the games work. Plot them, subtract the two values. Okay. There's another scenario though with your two dots, right? And this is the temperature. So again, I'm going to take the mass at the high temperature minus the mass at the lower temperature, and this is the mass that will precipitate out if I'm going from high to low. If I'm going from low to high, I can see how much more would dissolve. Okay, we're just going to plot the two. Okay, use table G to find out each amount, and then subtract the final from the initial. Okay, you're going to be writing that stuff down. We're going to get into doing it here in a second. I think we got a little bit more to talk about of how to do it, and then we're doing it. So finding solubility when the amount is greater than 100 grams of water. Now, this is where life gets tricky. Pay very careful attention. On the y-axis, it says the solubility, the grams of stuff, solute, per 100 grams of water. So this whole chart is based on 100 grams of water. It's not a lot of water. It's a little bit of water, okay? And then a temperature of said water. So I have temperature and volume. If I change the volume, I should change how much should dissolve. Makes sense, right? Not too complicated. So if the amount of water doubles to a 200 grams of water, then double the amount of stuff that would dissolve. And if it's halved, let's say they say 50 grams of water, then I half however much it would be. Just look it up and manipulate that number. So this is the last piece of the examples I'm going to do for you. We're going to use table G to find out the amount that would normally dissolve at that temperature and then manipulate it. If I have half the amount of water, well, then I have half of that number. If I have double the amount of water, then I have double that. I have an example where I said 2,000 grams of water, so that's 20 times more. I'm going to do my plot at that temperature and that stuff, see how many grams would normally go in, multiply my answer times 20, and I'm moving on with my life. Okay, so it's not the most complicated game in the world. Let's play. Oh, my bad. Last piece. Information. There are 3 that go down, and there's everybody else slopes up. So the slope up, solids slope up. So they increase their solubility as temperature goes. You see what I'm talking about? Everyone that slopes up is a solid. The opposite's true for gases because as temperature increases, their solubility goes down. Okay? The solubility decreases as temperature goes up, or I could say as their solubility goes up as temperature decreases. I mean, we can word our way into confusion, but these are the ones that slope down. They've sloped down, they're gases. There's only 3 of them. Okay, good. Now we can play some games for crying out loud. All right, first part, determining if it's saturated, unsaturated, or supersaturated. So remember, this is the first part that we just learned in the notes. Saturated is on the line, unsaturated below the line, supersaturated above the line. So first example, 60 grams of HCl in 100 grams of water, which is a lawyer statement, which means use the chart as it is, at 47 degrees. So I'm going to start at 47 degrees. I'm going to go up. Whoopsies, that went too fast. I'm going to cross those two. So 60 grams and 47 degrees. And notice that ends up just on the line of HCl. So this is where you're going to write saturated. I didn't have the word saturated fly in. You're going to see if y'all are listening. Just seeing if you're listening. Can you hear me now? Another example, 20 grams of KNO3 at 20 degrees. So I'm going to run 20 grams, 20 degrees, and see where it goes in relation to KNO3. So here's where they mark. I see that KNO3 is this real long, sloopy line, and it's below the line, so it is unsaturated. Good? Here we go. 70 grams NaNO3 at 10 degrees. So I'm going to run 10 degrees. I'm going to run 70 grams, see where they cross, and then where am I? Now notice that is on the line of NH3, but I'm not worried about NH3. I'm worried about NaNO3, and that's this line going this way over the top. So this is below that line, hence it is unsaturated. I really hope that you guys are listening, or otherwise you're going to probably be really confused. Some of the other ones where I had to do math, I did put the graphic up. Okay, so switching gears, right? Next piece down, finding the amount of solute added to 100 grams of water to make a saturated solution. Saturated solution means touching the line, right? So go to the line. So I'm going to go 40 degrees up to NaNO3 and read the grams. So here I'm going to start at 40 degrees and run up to NaNO3 and read the grams. I'm reading the grams. It's about 105, 106. I didn't put it in there for you. So yeah, 105, I'll take 106. I'm not real looking for 104. It's about 105. Everybody good with that? 105. Next one, KClO3, potassium chlorate, right, at 30 degrees. So I'm going to run 30 degrees up till I hit that line and stop, and then read how many grams. And reading that is about 11 grams. 11 grams should be added to make this solution. Notice, I didn't put 11 grams up there for you guys. Please be listening. KNO3 at 50 degrees. So let me start at 50 degrees and run up to KNO3. Read across, it's about 85, 86 grams. 85 is good between friends. There's always going to be a plus or minus 1 on these. Okay, and then when you have the math, it'll be plus or minus 2. Okay, because you could be wrong on one set, both numbers. All right, so find the mass that does not dissolve in solvent. Now here's where we got to do some math. Okay, so if 60 grams were added to 100 grams of water at 20 degrees, how many grams did not dissolve? Okay, so let's run 20 grams up to the line, and I see it should dissolve, about 35 grams or so? 34 grams, I might have said. So I have to take 60 minus 34. and I get 26. So you see how we did that? Now I could have plotted 60 also and then just subtracted, but there's really only, I don't really need to plot the 60. I only need to plot what it would actually be at that temperature for KNO3. So it would dissolve 34 grams. I put in 60. So how many didn't dissolve? Subtract those two numbers. Good? Okay, moving on. Same thing. 30 grams of KClO3 are added to 100 grams of water at 25 degrees. So let me run up to 25 degrees. I can get about 10 grams in or so, it says. So if I put in 30 and only 10 grams will dissolve, because it forms a saturated solution, then obviously 30 minus 10 is 20 grams of that powder is laying at the bottom of the beaker. And since we're here, let me talk about that. A solution that has powder at the bottom of it is a good indication that the solution is saturated, because if it wasn't saturated, that powder should dissolve still. It's not dissolving. Why? Because the solution itself is saturated and it can't hold anymore. Okay. Using all those words to kind of reason and logic our way through this. Okay, a few more examples, different kind of example now. So change in temperature. So now we got to look it up twice. You'll see that this is still doable. We're just going to subtract the two values. Okay, so I have 75 degrees is cooled to 15 degrees. How many grams will precipitate out? So in the notes we just took, we're just going to get those two values and subtract them. So I'm going to run 75 degrees up to NH4Cl. I'm going to run 15 degrees up to NH4Cl, subtract the 2 grams, and we're good. Ready? So 70 degrees, I should get about, 62 grams in. And then when I run it at 15 degrees, I get something like, I don't know, 35 or so. So I subtract those two numbers. Let's see if I pick 62 and 35. I picked 62 and 36. When I was zoomed in, I could see that there was a little bit above 35. So that's why there's a plus and minus 1. Okay, so 62 minus 36 is 26 grams. Notice I left those on so you could see why I was using the numbers that I was. Good. Next one, I'm going to do the same thing. I have a saturated solution of KNO3 at 50 is cooled to 25. So I'm going to run it at 50 and see how much went in. I'm going to run it at 25, see how much went in, and then subtract the two numbers. Pretty simple. So run it at 50 to KNO3, and I see that's about 85, 84, probably 84. And at 25 degrees, it's something like 41. 85 minus 41 is 43 grams precipitated out. I put in this much stuff. It dissolved, but then I cooled it. So now it won't hold that much stuff. So some of it's going to fall out and it'll stay saturated. How much fell out? 43 degrees. Notice this game is all about finding the 2 points and subtracting. No matter really what the scenario is, it's find the 2 points and subtract. So just say. I haven't found one really that's add yet. All right, find the mass of solute that can be added if I increase the temperature. So here I have a solution at 55 degrees is heated up to 65 degrees. How many more grams do I have to put into saturated? Because at 65, it should be able to hold more than at 55, right? So again, I'm going to run the two numbers. I'm going to run 55 up, see how many grams, run 65 up, see how many grams, subtract the two numbers, and we're done. So we still got to change the amount of water. So we got a few more of these. So it's 65 degrees. Or did I do 55 first? No, yeah, 55, and then I heat it up to 65. I go from 55 grams to 60 grams. So I say 60 minus 55 tells me I could put 5 more grams in. Okay. Same type of situation here. I got 20 degrees and 70 degrees of KNO3. So let me just plot the two. I set at 20 degrees, I got something like 35 or so grams. And then plot it again at 70, and I'm up to 132. So 132 minus 35 is 97 grams more I can put in if I change the temperature that much. Okay, good. I think all we got left is changing the amount of water. This is the tricky one, so I hope I haven't lost you guys yet. I hope you're still hanging in there. This is where the Regents really likes to play games. So it says, how many grams of water, if KNO3 is dissolved in 50 grams of water at 40 degrees. So now the 40 degrees doesn't change, but that 100 grams over there on the side does. How did I get from 100 grams to 50 grams? I divided by 2. So I'm just going to run my normal saturation, find out how many grams at 40 degrees of KNO3, and I'm going to divide that number by 2. Okay, so let's run it. 40 degrees, KNO3 is about 60, they had chose 64 grams. And I need to divide that by 2. I get 32 grams because if I have half the water, I should be able to dissolve half the stuff. This is the one that is going to be on the Regents exam, by the way. This is the game that they like to play at the state. So here I have dissolved in 2,000 grams of water. So I took that 100 grams of water and I multiplied it by 20. 2,000 grams is 2 liters. So that is not unheard of at 50 degrees Celsius. So I'm going to run 50 degrees Celsius up to KNO3 and see how much would fit into 100 grams of water. I'm going to take that number, I'm going to multiply it by 20, that's what I did to get from 100 grams of water up to 2,000 grams of water. Sorry, I multiplied by 20. And I'm going to do that to my answer, and I'll be done. So 50 degrees, run it up to KNO3, and I see it's about, 84 grams. So 85 grams, multiply that by 20. I need to put in 1,700 grams to make a saturated solution if I have 2 full liters of water, which makes very much sense. 2 liters of water is quite a bit. Okay, how many grams of KNO3 can be dissolved in 25 grams of water at 30 degrees? 25 grams of water. So how do I get from 100 to 25? I divided by 4. So I'm going to find my answer at 30 degrees and divide by 4. Okay. Do you see that there's really no major equation to use there? How did I manipulate that grams of water? I divided by 4, so I'm going to do that to my answer. So 30 degrees, go up to my line, KNO3. Looks to me like it's about 48. I see it's a little bit lower than 49. 48 divided by 4 is 12 grams. And with that, we're done. You got lots and lots of practice on all these different games we played. I gave you examples of like 4 different games to play using table G: saturated, unsaturated, supersaturated. How much more can I add? How much precipitated out? How much didn't dissolve? What if I change the amount of water? So we got lots and lots of practice. You'll see in my practice packet, I put the squiggly line in front, which means approximately. You need to do your best. If you are not on the line, do not call it the 60 or 70. If it's just above the line, you need to go to that up 1. So you guys do need to be as careful as you can reading these things, but you do get just a smidgen bit of leeway. All right. And with that, lots of practice.